Hello, my dear students. Welcome to the session. In the last session, we have discussed the step-by-step approach to determine initial conditions. Okay. So this session we start with the problems. Okay. So let's look at the first problem. The first problem is like this. You can go through that in the classroom workbook, chapter 3, and topic is of initial conditions in the question number 1. Okay. What is the question written over there? Just read that. Let me read it. The given circuit is in steady state for a long time with the switch K kept open. At t equal to 0, the switch is closed. At t equal to 0, the switch is closed. Then determine the values of I of 0 plus d I of 0 plus by dt, d square I of 0 plus by dt square. Understand all of it? Okay? Whenever you come across 0 plus conditions, we should always remember that 3-step approach and we should apply step by step to avoid the confusion. Okay. So first let me write clearly the step-by-step approach, okay, to solve this problem. Step 1. Step 1. For t equal to 0 plus conditions, what is the step 1? Construct t equal to 0 minus equivalent. Okay, t equal to 0 minus, looking at the switch condition, okay. Sometimes he doesn't give the description of the problem. He will directly indicate the direction of the switch. Okay, and we already know that the assumption the circuit will be in steady state until the switching operation is taken place. So even if he mentions or if he doesn't mention, okay, you should understand that the network is always in steady state before switching operation. Otherwise, you cannot go for the transient analysis. We already made it very clear in the last session. Okay, t equal to 0 minus, the switch is open. What is the equivalent? Just look at this. Resistor, inductor is acting like a short circuit. This is an inductor. Remember all of you. And this is what the voltage source already given. That's it. So the current flowing here is I of 0 minus. I of 0 minus and IL of 0 minus both are same because current I is the current through the inductor. Okay, current through the inductor. You can say what is current through the resistor? Yes, current through the resistor also same as what current through inductor because both are connected in series. But you should take current I is through inductor. It may not change instantaneously, and resistor is supposed to follow the inductor only. Okay. Therefore, here what is I of 0 minus? I of 0 minus is because it is open circuit, it's 0. And he's asking I of 0 plus, but what is I? Look at this, what is I? I is current through inductor. Current through inductor may not change instantaneously. Therefore, I of 0 plus is equal to what? I of 0 minus is equal to what? 0. Understand all of it? Okay? So you got the first question answer here. And step 2, is it required? Step 2, because step 2 generally, when do you go for step 2? Tell me. Other than current through inductor and voltage across capacitor, okay, only for those quantities, you generally go for what? Step 2. But here, what is I? It is I is current through inductor. You can say, sir, current through resistor, but current through inductor. Current through resistor will follow the current through inductor. If current through inductor may not change instantaneously because it is in series with inductor, because the resistor is in series with inductor, current through resistor also may not change instantaneously. Understand all of you? Okay? Because it is in series with the inductor. Okay? Well, so second step is not required. What is third step? Step 3. Should we really go for step 3? Because there are some derivative terms, we must go for it. And in step 3, I told you already to obtain the differential equation for t greater than 0. For t greater than 0, switch is closed. Resistor remain resistor, inductor remain inductor because t greater than 0, we do not know the specific time. T greater than 0 means just greater than 0. It might be 1 second, 2 second, 0.1 second, or whatever it is. So therefore, if you draw the differential equation, if you obtain the differential equation, it is IR plus L d I of t by dt, okay, d I of t by dt, I of t into R, okay, is equal to what? V. From this, okay, let us assume that is equation 1. Apply t equal to 0 plus conditions to equation 1. I of 0 plus into R, L d I of 0 plus by dt, is equal to V. You know that this value is 0 because already we determined this value. And we need di of 0 plus by dt. Di of 0 plus by dt is equal to V by, okay, L. What is V? 100 volts given already. L is 1 Henry. 1 Henry, 100 by 1. It is amperes per second. Amperes per second. Okay. But we want the d square I of 0 plus by dt square. For that, don't differentiate this, okay? Don't do that silly mistake, okay? You differentiate equation 1. D of equation 1 by dt will give you di of t by dt into R plus L d square I of t by dt square is equal to 0. Call this is equation 2. Now apply t equal to 0 plus conditions to equation 2. So what do you get here? D I of 0 plus by dt, I of 0 plus by dt into R, L d square I of 0 plus by dt square, okay, is equal to 0. Now if you substitute here, it's already 100 and you just send it out, then minus R by L, yes or no? So d square I of 0 plus by dt square is equal to minus R by L. What is R actually here? 10 ohm. L is 1 Henry. So minus 10 by 1 into, what is this value actually here? This is 100. Yes or no? So into 100. Minus 10 power 3 ampere per second square. Okay, so this is ampere per second, velocity component. This is an acceleration component because amperes per second square. And current is in amperes. Yes or no? This is how you generally solve the problem. Okay, so please note down quickly here. And meanwhile, I just note down another problem. Note down this. Note down the problem. Question number 2. Please note down. Question number 2. C is equal to 1 microfarad. R is equal to 1 kilo ohm. Voltage V is equal to 100 volts. Okay. This is I of t. So expected to determine I of 0 plus d I of 0 plus by dt d square I of 0 plus by dt square. Okay. Hope I think all of you done with this problem, right? Now look at the second question. Second question. Look at the second question. Now in place of inductor, capacitor is placed. Now you will understand the step-by-step approach and the difference and all, okay? So let me do again a step-by-step approach. Step 1. What is step 1? Again construct T equal to 0 minus equivalent. How does it look like? Resistor remain resistor. Capacitor becomes open. At T equal to 0 minus and T equal to minus infinity, both are same, right? We already discussed that. This is open. This is also acting like an open circuit, but physically capacitor is available. So this is the resistor and this is what, okay? But in step 1, what is your objective? What are you trying to find in step 1? In our three-step approach, you can see the first step, our objective is to determine current through inductor and voltage across capacitor. You understand? We don't find any other, okay? We want just current through inductor and voltage across capacitor, irrespective of the question given. Understand all of you? Okay. What is the question actually asked here? Current I of 0 plus. But what is I? Current through resistor and current through capacitor. Yes or no, all of you? Whatever the question it might be, we don't bother about that. In the first step, our concentration is always on finding current through inductor, voltage across capacitor. That's it. Understand? Okay. So my objective is to find Vc of 0 minus. So since it is an open circuit, you can't send any charge to the capacitor, then obviously the voltage across the capacitor is 0. And why you want to find this voltage across capacitor? Because what is the question asked actually here? I of 0 plus. Okay. I is not current through inductor. Other than current through inductor, you have to go for step 2. What is step 2? Construct T equal to 0 plus equivalent circuit. Okay, T equal to 0 plus equivalent circuit depends on what? Current through inductor and voltage across capacitor, T equal to 0 minus. If you do not know those values, you cannot construct T equal to 0 plus equivalent. Therefore, that is why I am calculating Vc of 0 minus. Okay, now, step 2. Step 2. Construct T equal to 0 plus equivalent. How does it look like? Switch. 0 plus means switch happened, right? Switching operation already taken place. So therefore it is closed. Look at the direction of the switch. Initially it is open. The direction of the switch is nothing but you are closing at T equal to 0. That means already it was open condition. Now you are closing at T equal to 0. So resistor remain. Resistor. Capacitor becomes what? Capacitor becomes what? Voltage 0 refers to what? Short circuit. We already learned this particular one in the table. We discussed in the table. I think all of you remember that. Okay. What about this V? This is R. Okay. Now you need to find, this is actually corresponding to 0 plus conditions. Therefore, I get the value of 0 plus. Understand all of you? Now I want I of 0 plus. So what is I of 0 plus? Simply V by R. What is V? 100 volt by 1 kilo ohm. 0.1 ampere. Okay. Now, let us find the derivative terms. What are the derivative terms? Look at this. You can finish that, all of you. Okay. You can finish that. All of you, please note down that. Note down that. And I go for step 3. Why I want to go for step 3? Tell me, all of you. Step 3 I am going for because higher order derivative terms are required. Initial conditions of higher order terms. So therefore, so what do you get here? IR, I of t into R plus 1 by C integral I of t dt is equal to V. Equation 1. Since you do not have your desired term di of t by dt, let us differentiate this equation 1. Equation 1 with respect to t. What will you get? Di of t by dt into R plus 1 by C I of t is equal to 0. Now you call it equation 2. Applying t equal to 0 plus conditions to equation 2. Di of 0 plus by dt into R, okay, or is equal to minus 1 by RC into I of 0 plus. Already you know what is I of 0 plus. Minus 1 by, this is 10 power 3, this is 10 power minus 6 into 0.1. So this is already 10 power 3. Okay, yes or no, all of you? 10 power minus 3, but you take it to the numerator, 10 power plus 3 into 0.1, it will become minus 100. Minus 100 amperes per second. You understand all of you? Okay. Now differentiate equation 2, because I would like to go for what? D square. Okay. For that, let me differentiate this equation with respect to t. So what will I get here? Tell me, all of you. D square I of t by dt square minus 1 by RC di of t by dt. Agree, all of you? So now let us apply t equal to 0 plus conditions. Then what will I get? D square I of 0 plus by dt square is equal to minus 1 by, once again here what, 10 power 3 into 10 power minus 6, okay, into minus 100. So what will you get? It's already minus into minus plus 10 power 3 into 100, 10 power 5 amperes per second square. So this is how you are supposed to solve the problems. Okay, do it all of you. Complete it all of you. Okay. Understood all of you? Okay. So now question number 3. You can complete that. Meanwhile, I just note down this problem. Your classroom workbook, question number 3. I is equal to 10 ampere. Okay. D square V of 0 plus by D square. Classroom workbook, question number 3. Classroom workbook, question number 3. Classroom workbook, question number 3. Okay. Now there is a parallel circuit. Okay. That's a parallel circuit. Step 1. Step 1. What is step 1? Construct T equal to 0 minus equivalent. Look at the switching operation. Initially closed, at T equal to 0, it is open. See, whenever these kind of networks are given, your concentration must be on the switching operation, how it is actually operated. Initially, it is closed. Look at the direction. Initially, it is closed. Now, you are opening the switch at T equal to 0. So, T equal to 0 minus, obviously, in this particular problem, it is in closed condition. Yes or no, all of you? Now, tell me how the network looks like. Okay. Closed. Resistor. Capacitor is acting like what? Open circuit. What is our objective in the first step all the time? Always your concentration must be on voltage across the capacitor and current through inductor. Of course, there is no inductor, but there is a capacitor. Plus minus. Vc of 0 minus is 0. But here, V and Vc of 0 minus both are same. Therefore, V of 0 minus is 0 and you already want V of 0 plus and V is the voltage across the capacitor. I can say V of 0 plus is equal to what? V of 0 minus, which is nothing but 0. Second step is not required, sir, all of you. Reason? What is the reason? You want voltage across capacitor. Usually voltage across capacitor T equal to 0 plus can be obtained from step 1 itself. There is no need to go for step 2. Therefore, step 2 is not required in this context. But step 3 is required. What is step 3? Okay, it is for higher order derivative terms. In case of higher order derivative terms, to determine, you need an equation, a differential equation for t greater than 0, either using KCL or KVL. Since it is in terms of voltage, usually you get the voltage. Okay, the equation in terms of voltage will be obtained only in case of node analysis. Node analysis, actually, you know very well, it deals with the Kirchhoff's current law. Okay, so therefore, let me apply KCL at node, this particular node. Then for t greater than 0, I get, what is that? V of t by r plus C dV of t by dt is equal to what? I. Yes or no? Okay, equation 1. Let us apply t equal to 0 plus conditions. Then what will I get here? Okay, what will I get here? V of 0 plus by r plus C dV of 0 plus by dt is equal to I. You know that this is 0. Therefore, dV of 0 plus by dt is equal to I by C. What is I? What is I actually here? The value of I is 10. What is C here? 1 microfarad. 10 power minus 6. And finally you got 10 power plus 7. Okay, volts per second. Is it clear, all of you? Okay. Next, we want higher order. Let us again differentiate. D equation 1 by dt will give you dV of t by dt, okay, into 1 by r plus C d square V of t by dt square is equal to, since it is constant, it's a DC, it's a constant value, therefore it will become what? 0. Okay. So let us take it as equation 2. Now let us apply t equal to 0 plus. Okay. This is to equation 1. This is to equation 2. Therefore, you want d square V of 0 plus by dt square. Okay. Again minus 1 by RC into dV of 0 plus by dt. Yes or no, all of you? This is already R into C combination. 1 kilo into 1 micro will give you 10 power minus 3. And if you take it to the numerator 10 power plus 3 into 10 power 7, already this value you already determined. Finally, minus 10 power, okay, this will give you plus 10 volts per second square. Understand, all of you? Okay. So this is how you can solve the problems. Quickly, please note down. Meanwhile, I'll just note another problem here. Question number 4. Please complete that, all of you. Question number 4. Classroom workbook, question number 4. I just note down the problem meanwhile. Please complete this. These examples are very simple, easy to understand, the further problems. But don't expect this level problems will come in the exam, because in exam you are getting a little higher level. Okay. Okay. Again, V of 0 plus dV of 0 plus by dt d square V of 0 plus by dt square. Okay. Question number 4. All of you, please go for question number 4. Question number 4. Okay. So step 1, start. Start with step 1. All of you. Okay. Step 1. Let's go with step 1. Construct t equal to 0 minus equivalent. What is t equal to 0 minus equivalent? Switch is closed. Still it is closed position at t equal to 0 minus. You are opening at t equal to 0. So resistor remain resistor. Inductor is acting like what? Short circuit. Yes or no? This is an inductor. What is your objective all the time for a given network? Okay. If you want to find t equal to 0 plus conditions, you must know at t equal to 0 minus what is the current through inductor and voltage capacitor. Yes or no? So irrespective of the problem, whatever the problem it might be, whether it is voltage or anything it might be, your objective is all the time what is the current flowing through the inductor at t equal to 0 minus. This is your requirement in step 1. Okay. Your ultimate requirement is V of 0 plus. That's a different story. But as far as step 1 is concerned, you are supposed to determine only current through inductor at t equal to 0 minus. So now tell me what is the current actually. Here it is 1 ampere. Okay. This is a resistor. This is acting like a short. This is also acting like a short. Physically, physically it looks like there are two short circuits. But common sense that there is an inductor physically. Can you charge inductor keeping a short circuit across it? It's not possible. Therefore, the current flowing to the inductor is 0. Okay, and you are going to use this particular information in step 2 because your objective is what actually here? V of 0 plus. What is V? V is the voltage across the resistor. V is the voltage across the inductor otherwise. Other than voltage across capacitor, you have to go for step 2. That is why step. What is step 2? Switch open. Yes or no? You're opening the switches at t equal to 0. Resistor remain resistor. Inductor is acting like what? See, this is 0 current. Current 0 refers to what? Open circuit. Consult the table, all of you. Consult the table. The table gives you at t equal to 0 plus, the equivalent of inductor depends on current flowing through the inductor at t equal to 0 minus. Current 0 refers to open circuit. That's what we actually given in the table. You please go through the table. Okay? Right. But physical inductor is available, but behaving like an open circuit at only t equal to 0 plus. Okay? So what is this actually R? And you want V of 0 plus. Now this V of 0 plus is nothing but voltage across the resistor or voltage across the inductor, whatever it is. Now the entire current is passing through it. This is 1 ampere. Therefore, V of 0 plus is 1 into R value is how much? 100. Therefore, 100 volts. That's it. Now step 3 is required because of higher order derivative terms. For t greater than 0, let me write here V of t by R plus 1 by L integral V of t dt is equal to I, equation 1. But you can't really get anything out of it because of the integration. Therefore, go for differentiation of equation 1. What will you get? dV of t by dt into 1 by R plus V of t by L is equal to 0. This is what actually you get. So call it equation 2. T equal to 0 plus conditions to equation 2. So what will you get? dV of 0 plus by dt is nothing but minus R by L into V of 0 plus. So what is the value you get here? V of 0 plus is already 100. L is 1 Henry and R is 100. 100 into 100. So minus 10 power 4, okay, volts per second. Yes or no? Now again you differentiate with respect to t, that equation 2, okay, d of 2 by dt will give you, okay, d square V of t by dt square into 1 by R, okay, or else you can directly write is equal to, what do you get, minus R by L dV of t by dt, equation 3. Now apply t equal to 0 plus conditions to equation 3. d square v by okay, d square v of 0 plus pi dt square is equal to minus r by L dv of 0 plus by dt. Okay, now let us substitute, all of you substitute that value. Substitute that value and get some answer. I think you can get it easily. Those values, if I substitute minus 100 by 1 Henry, yes or no? Into what? What is dv of 0 plus by dt? You already got that answer, minus 10 power 4. So what do you get? 10 power 6 volts per second square. So this is how you are supposed to solve. These are all simple basic problems. You can't expect the same level of problems in the exam because they're all basic problems. Okay, but you get a clear idea that how you apply step 1, step 2, step 3. Okay, these are all very, very important. So quickly complete that. Hope I think you have finished this. Quickly complete. An important point to be noted down here. Okay, I think you have finished this, right? So all of you, just look at here for a moment. I would like to explain you some important observation here. See, in the exam, usually you get either a non-derivative term or a first order derivative term. You take any competitive exam, okay? Whether it is GATE or IES or any government undertaking company, the written test part when they conduct, you get always either a non-derivative term I of 0 plus or else first order derivative term d I of 0 plus by dt. Because for these kind of circuits, either series or parallel, finding the higher order derivative terms is not a difficult deal. Yes or no, all of you, okay? Because you can obtain the differential equation easily, okay? And you can further proceed how we have actually calculated, you already observed, okay? But when you have a complex network, like for example, you have a network like this. Okay, you have a network like this. Assume that there is a network something like this. This is I1 and this is I2. For example, you are asked to find di2 by dt of 0 plus d square I of 1 of 0 plus by dt square, yes or no? Or let us say 2, otherwise it's not a problem. You can take 2 or 1, doesn't matter. So like this, the questions have come, let us say, in the exam. How do you find it again? Whenever you are asked to find the derivative terms, usually you are supposed to obtain the differential equation in terms of the desired quantity. For example, you require dv of 0 plus by dt, then entire differential equation must be in terms of what? dv by dt only. Yes or no, all of you? Only in terms of v of t it is supposed to be expressed. So here, now even if you want I2, di2 by dt or d square I2 by dt square and all, if you want to really get, okay, the differential equation in terms of I2, when you have multiple loops or when you have multiple nodes, let us say, then getting the differential equation in terms of the desired quantities will be definitely a difficult task. I don't say it is impossible, but it is a time-taking process. That is why most of the time such kind of problems are not given in the exam. Okay, the higher order derivative terms may not be asked. You will be asked only the first order derivative term. In that also, okay, you will be asked the first order derivative terms where Okay, di of 0 plus by dt, where I is the current through the inductor. That means dIL of 0 plus by dt. And dV of 0 plus by dt, where V is the voltage across capacitor, dVc of 0 plus by dt. For these two terms, without obtaining the differential equation, okay, without taking too much of time to obtain the differential equation, you can easily determine only these two quantities. I hope you understand. In the exam so far, okay, it is asked only the first order derivative terms, either dIL of 0 plus by dt or dVc of 0 plus by dt. Understand all of you? In case for any reason unexpectedly, if you get okay a question which consists of other than current through inductor and voltage across capacitor, the derivative terms first order, or else any higher order derivative terms, definitely you have to go for the step-by-step approach, the third step, without any hesitation or without any failure in that. Understand all of you? Okay, but these two quantities can be determined without obtaining the differential equation. I repeat once again, the difficulty involved in all these things, the step 3 particularly, obtaining the differential equation for t greater than 0 in terms of the desired quantities itself is a difficult task. It will take a lot of time. Understand all of you? Okay. So therefore, now I am giving you some simple way of calculation here to determine only first order, as only first order terms are asked in the exam. Okay. So look at this, all of you. Look at this, all of you. Okay. So what is the step-by-step approach? First step is construct t equal to 0 minus. Second step is what? Construct t equal to 0 plus when other than current through inductor and voltage across capacitor are asked. And go for step 3. Obtain the differential equation for t greater than 0 when higher order differential terms or derivative terms are asked. Okay. But now the first order derivative terms can also be determined only from step 2 without going for step 3. Okay, so just note down here, put a note and write down. Put a note and write down. The first order derivative terms. The first order derivative terms of dIL of 0 plus by dt. It's very clear where I is current through inductor, and dVc of 0 plus by dt can be determined okay from step 2 only. From step 2 only, without going for step 3. Without going for step 3, you can find it from step 2 itself. Is it clear all of you? Okay, how it is? Let us look at this. So let me justify it, because I gave a statement, I need to justify it. So you know that in case of inductor L, okay, V L of t, this is IL of t. We know that VL of t is equal to okay L dIL of t by dt. So is it not a differential equation? Yes, definitely. If you apply t equal to 0 plus conditions to it, what will you get? dIL of 0 plus by dt will be nothing but what? VL of 0 plus by L. So how do you find this VL of 0 plus? You can find that VL of 0 plus from step 2 only. Voltage across the inductor at t equal to 0 plus can be determined from step 2 or not. If you know that, divided by L will give you dIL of 0 plus by dt. So you are able to find this first order derivative term without going for step 3, just by step 2 only. Okay. Now second one is Vc of t. Now what do you get here? Ic of t is equal to C dVc of t by dt. From this, t equal to 0 plus conditions, you will get dVc of 0 plus by dt will be nothing but Ic of 0 plus by c. So it's very clear from these two expressions that this particular one and this particular one can be determined from step 2. Step 2 only you can determine these two quantities. Yes or no, all of you? Current through capacitor can be determined at step 2 only. Voltage across the inductor, current through capacitor at t equal to 0 plus can be determined from step 2 only. Step 2 only. From step 2 only. Please note down that. That's very, very important point. So now onwards, for first order derivative terms, particularly when I is current through inductor, V is the problem, and the session may end. Session may end in the middle of solving the problem. Don't worry, that will be continued in the next session. Now question number 5. Read the question number 5. Read the question number 5. It is there in your workbook. Classroom workbook, question number 5. It's very clear. In the network shown below, the switch is moved from position A to B at t equal to 0. Solve for I by dt at t equal to 0 plus if R, L, C, V values are given as shown. So now let me draw it meanwhile. So this is what I of t. R value is given. L value is 1 Henry, 0.1 microfarad. This is A. At t equal to 0, the switch is moved from A to B. So what is asked actually here in the problem? Please go through that problem, all of you. I di by dt at t equal to 0 plus. What is the value of V given? V is 100 volt. This is actually 100 volts. Switch is moved from A to B. That means what? The switch is, when the switch is at A, the network was in steady state. Yes or no, all of you? Then at t equal to 0, the switch is moved to B. Now let's try to find the things asked, in the problem. So well, what is actually asked in the problem? Always whenever this t equal to 0 plus conditions are asked, your focus must be on which quantity asked here. I. What is I first? I is current through inductor. You can ask me, sir, current through resistor, but current through inductor. I told you already, when there is a resistor connected in series with the inductor, current through resistor will also follow the similar behavior of what? Current through the inductor. As a matter of fact, any element which is in series with the inductor, that has to follow, that current should follow the current of the inductor only. Therefore, look at this here, current through inductor. Step 1. Definitely from the problem itself we will understand From step 1 only you will get the answer here I of 0 plus without going for step 2. But what is the another quantity asked here? Derivative term. According to the old procedure what we discussed in the initial stage of this particular chapter, I told you go for what? Step 3. But now just now I discussed the first order derivative term, particularly when I is current through inductor, you can determine that particular quantity only from step 2 without going for step 3. Yes or no, all of you? Let us not waste our valuable time going for step 3. It will take a lot of time because you have to obtain the differential equation and do a lot of things. Okay. So let us do that. Now, t equal to 0 minus equivalent. What is the t equal to 0 minus equivalent? Switch is at A and circuit, and this is isolated. Yes or no, all of this is acting like a short circuit. Now the circuit becomes like this. This is the switch. Inductor is acting like a short circuit. Capacitor is acting like an open circuit. The resistor is R. Okay. Now this is 1 Henry. This is 1000 ohm. Okay. Now this is actually V. Yes or no, all of you? This is what the current actually given. This is now I of 0 minus. So what is I of 0 minus? V by R. What is V? 100. What is R? 1000.